Let's see what happens to carbohydrate as it goes through the digestion process. The food will enter the mouth, where carbohydrates will get mechanically broken down by the teeth and the tongue. Saliva will be secreted by the salivary glands. Within the saliva is an enzyme called salivary amylase. Salivary amylase will start working on the alpha bonds between the glucose molecule to start breaking down the bigger starch molecule into smaller starch molecules. Since you don't hold food in your mouth for too long, the sugar digestion cannot fully take place in the mouth. Once swallowed, it will travel down the esophagus and make its way into the stomach. Because the stomach is so acidic, the low pH inactivates the salivary amylase, and the carbohydrate digestion just comes to a stop. The fibers will remain in the stomach longer, which means that you're going to feel fuller longer if you consume high fiber foods. But no digestion takes place in the stomach. Slowly, the chyme, containing the carbohydrates, will be emptied into the small intestine. The duodenum, being the first part of the small intestine, will be receiving enzymes from the pancreas. Small intestine will secrete pancreatic amylase to start breaking down the big molecules into smaller molecules. Once the molecules are broken down to disaccharides, specific enzymes will help break down the disaccharides into monosaccharides. These enzymes are located on the intestinal epithelial cells. For maltose, you'll have maltase, which will break down the two glucose molecules. For sucrose, you'll have sucrase, which will break down glucose and fructose. And lactose will be broken down to glucose and galactose with the help of lactase. You've probably heard of lactose intolerance. Well, people who are lactose intolerant do not produce enough lactase, which means they can't break down that molecule into glucose and galactose. What happens then is that it tends to attract water, causing bloating, which can be quite painful at the intestinal level. For carbohydrate absorption in the small intestine, while only monosaccharides can be absorbed, which means you have to break down the starch into smaller starch and then eventually disaccharides and eventually monosaccharides. Glucose and galactose will be absorbed through active transport, which means there'll be a transporter protein across the membrane. They'll use up energy and they'll move the glucose and the galactose into the bloodstream. Fructose, on the other hand, works with passive diffusion. Passive diffusion is quite a bit slower, which means that the sugar will enter the bloodstream at a slower rate if you consume fructose than it will if you consume glucose and galactose. Once the glucose, fructose, and galactose are absorbed, it will travel through the bloodstream through the portal vein to the liver. The liver will convert the fructose and the galactose into glucose. So now you have nothing but glucose in your body. Well, the liver is a bit of a command center. It'll decide where these glucose need to travel to. They'll either stay in the liver, get rebonded together into large glycogen molecules and be stored, or they'll travel to muscles where again they'll be reassembled as glycogen, or they'll be sent to whatever cell needs energy at that time. So it can either be used for energy directly, stored as glycogen, or be sent off to be stored. If glycogen stores are full, you can imagine what will happen to sugar. It will be stored as adipose tissue or fat. How does the liver manage all this? Well, it converts glucose into glycogen through glycogenesis. Glycogenesis requires glycogen synthase, which is an enzyme that can reattach or rebond all the glucose molecules into long glycogen molecules. If the liver then needs energy, it can break down glycogen back into glucose through glycogenolysis, which can then use the glucose for energy. I'm going to give you a few minutes on this slide to recap digestion of the carbohydrates.